Oh, it completed. Okay. Well, alright. Because it completed, let's go look. Okay. Why is this single eye so weird here?
Because you're not paying for it.
I guess, yeah. So Aristotle finished successfully. Okay. I've written a complete, verified, lean for proof that for any prime p greater than 3, 24 divides p squared minus 1. The proof is in this file. Okay? There's the theorem statement itself. And weird, lean specific syntax there. That 24 is a divisor of p squared minus 1. Given that p is a natural, that it has the hyper property that it is prime, and it also has the hyper property that it is greater than 3. Yeah, and so then it's got the different steps involved in the proof here. Okay. Well, I will go and collect this data, and I will go and dump it out into the Zulip later, so we can have it and poke around with it a little bit, which is actually relevant to a thing we'll get to here in a minute as well.
Did you have to be logged in and create an account to do what you just did?
Yeah.
Okay.
But to log in to create an account, it's just, you can use Google login.
Yeah.
So, oh, we got my ping live. Ready. I'm not as worried about the recording of my part as your part, so I'm gonna vamp a little bit. All right, here we go. Welcome to the Austin Formal Methods user group this month. We have special guest speakers from URSA Secure, so very excited to hear what they're working on and bringing a formal methods startup into reality. It's kind of an interesting topic, definitely an area that I am very curious about, and I think there's others in this room who also aspire to similar things. But before we get started, we want to thank our sponsors. And first up, Station Austin. We still have the old Capital Factory logo here as well, but it is the place to go for, you know, being in the startup world here in Austin. If you're interested in getting a membership, we've got direct links or whatever to just let them know that you're coming here. But they're, as always, we're very grateful that they give us space for free here, and the best location you can get with that hell of a view, the Capitol and everything. So, in addition, Zulip is a sponsor as well, because they give us free Zulip access, and that is where I will be uploading this information later. So if you need access to our Zulip, contact Rob or I. Both have the ability. I think there's a few others who may also have the ability to add folks. We do not have open invitations on there so that we can avoid some of the spam, but anybody who's here will definitely get you an invite sent. And we have a landing page. This is useful for getting to the Meetup page to see where we're going to be meeting and things like that. Also, it's got a link to the recordings which we have on YouTube. So not every meeting is able to be recorded, but the ones that are recorded, we collect them, put them into a playlist there so you can enjoy them later. And as a reminder, I like to try to make sure that we're all on the same page, because formal methods is such a broad area that this is usually the definition that we stick with, which is formal methods are techniques and tools which use rigorous mathematical logic to design, analyze, and verify systems with provable properties like correctness, reliability, and security. It doesn't necessarily mean that we're only making proofs. It doesn't necessarily mean that we're only talking about mathematics or only talking about computer science. It's just, in general, talking about using mathematical approaches to problems, and a lot of times those problems involve things which we could, at least in theory, be able to make proofs about. It's a different kind of conversation than we we would be having with just talking about testing, for example, for software. Of note, so next month we will not be able to meet here. Every year in June they have their big event for the internal folks here at Capital Factory. Once again, that just happens to be the week that our group's going to be meeting. So I think we'll be able to meet at Diogenes. Is that right? Next month?
Yes.
Okay, cool. So next month we will be meeting at Diogenes. We'll have the information up on the Meetup page. I'll go get it up there. Another thing to note, something we've been talking about for a while, and I think we're gonna start this next month. You see, before the pandemic, the first version of this group, we were meeting twice a month up at the Barnes and Noble on the north side to kind of do a study session, a hackathon session, whatever you want to call it, where we were going through just trying to use the tools, trying to go through tutorials, go through books and things like that. Sounds like we've got enough interest that has developed at this point, so we're going to start that up again. What we're going to be doing is on the second Sunday. So, you know, our regular meetings, nothing's going to change about that. We're still going to be meeting here when we can, and when we can't, we'll be meeting at Diogenes. And that's the fourth Wednesday, as always. But in addition, we're going to have on the second Sunday, we're going to try for now, see how well it goes. Maybe from like 1 till 4 p.m., something like that, up at the Bennu on the north side. So Bennu over by ACC. Yeah, on the north campus. Yeah. So the Highland area. So we're going to be meeting up there. We'll put the information up on Meetup either later today or tomorrow for that. So if anybody is interested, we're going to try it, see how that goes. That is not going to be presentation style. That's just going to be bring your laptop, bring your formal methods books, you know, paper and pencil if you want to go write some proofs yourself, whatever it's going to be. You know, hopefully a computer if you're writing proofs, but you know, to each their own. And we're going to play around with the tools and see what we can do with that. It was a group that worked really well before the pandemic. We found it was very difficult for newer folks to be able to jump in a meaningful way, which is part of the reason why this version of the group was, you know, brought into existence, was because this is a lot more approachable. But if you want to go get your hands dirty and actually work around in this stuff, that's what we're going to try to start doing again. So it'll be second Sunday of every month, and we'll have the details up on the Meetup page. So now, let's see if Elijah has started our stuff. All right, cool. We are good. We've got guest speakers from URSA Secure. Very excited to have them here, and without any further ado.
You gotta get up here too. Nice try. Look, quiet.
And I want to introduce the other
My name is David Kovar. This is Rob Cutler. URSA Secure. First of all, you all are interested in formal methods. One question is, why are you interested in formal methods? And the second question is, how many are you interested in startups? And the reason I ask that is because a lot of what the reason we're here is because we've been working with Capital Factory to take formal method work that we did for DARPA and turn it into a real world product. And if you're interested in that part of the journey, then there's some materials I'll throw in. If you're not, you're not. So how many people are interested in sort of that startup work? Okay, there we go. So yeah, so there, we have a fair bit of material on the startup arc. We also have a lot of technical material on what we're doing, and we can share more technical detail about what we're doing afterwards. And we are actually releasing a product, and you can sign up to be beta testers or alpha testers for the product. So I'll share all that information at the end of this. For some reason, there were 2 audio tracks, which makes me think I messed this up somehow.
Hello, I'm Wed May, DARPA Program Manager at Antone, and I want to introduce the URSA Cyber First.
That is very weird. That was you. That's me. I know what I'm.
That's you?
No, this is Bernie. Yeah, this is Bernie, but for some reason, there's a second audio track to this which should not be here. And I don't know how to get rid of it. Alright, I will just talk about this then. We were doing what's called a Cyber Phase 2 for DARPA that started in 2024. And it finished in early 2025. So it started in 2023, ended in early 2025. And the whole concept was we were trying to automate semi-automate firmware reverse engineering. We were trying to make it easier for people that were doing really labor-intensive reverse engineering to automate some of the really sort of tedious parts of the process so they could be more efficient. At the 6 months before the contract was supposed to end, we got a new program manager, and that program manager was open to sort of recalibrating what we were doing and making it more modern and more relevant. And so what we did is we made a simulated pacemaker, and we conducted a cyber attack against that pacemaker, which caused the pacemaker to fail. And our self-healing capability detected that it failed through anomaly detection. And then it created, using the modern AI LLMs of 2025, it created a patch. And then it applied the patch in real time to the simulated pacemaker and got it running again, which we thought was cool. And it was cool. But Bernie, so we finished up the contract, we closed it out, and Bernie sent me an email or called me like about a week after we finished the contract and said, you know, if you put a little bit more effort into this, people are going to be really psyched about it. Like, what did we not do? Well, you used formal methods to prove that this AI-generated patch was equivalent to the original code. That was good, but you didn't really do it well enough. It's like, all right, what do you want done? And do you remember what he said? What exactly he wanted you to do?
Well, it was also about being able to show that everything could be done within a certain period of time.
So we had done it sort of semi-manually for the purposes of the proof of concept, but it's like, okay, you gotta go do this in a more rigorous way. So Rob put about a month worth of work into that, which was really the prototype for full method. So we proved that running on a Mac, we could call out to ChatGPT, I think what we were using at the time. It would generate a patch. It would run through our formal methods equivalence check, in the whole thing, and apply the patch back to the pacemaker in under 16 seconds. So he made a video about it, which is just like freakishly rare. So our DARPA PM liked what we were doing so much that he promoted us. And so now if somebody says, you know, prove to me that you've got something, it's like, well, Bernie McShay put it up on the DARPA website, so that's pretty cool. We, including Bernie, thought that the really cool thing was we were making a self-healing system. We were making a system that could detect when it was under a cyber attack and fix itself. And so he was sort of beating the bushes around the Department of Defense, and things like that. And I was beating bushes around sort of commercial space and things like that. And every once in a while we would check in with each other, because he was no longer our program manager. And we were like, man, I had this really good meeting with these people, but it went nowhere. And we eventually figured out that it was just so advanced that there was no one willing to fund it. There was no one willing to say, hey, if we give you a chunk of money, you'll have something for us that works in a reasonable amount of time, like 2 years. And so about this time, another thing that happened that Bernie did for us, Bernie put us in, nominated us for a DARPA EEI program, Embedded Entrepreneur Initiative Program. And what that does is if you get nominated, and then you get through due diligence, and then the due diligence gets through the panel review, they will give you a chunk of money to fill some sort of commercialization role, sales, marketing, biz dev, things like that. So he nominated us in March. We were finally connected with Capital Factory, who was doing our due diligence, in October-ish timeframe. The due diligence required another 6 weeks, which was really very cool 6 weeks, because it's kind of like going through a startup accelerator in a very compressed amount of time. And it helped us sort of get better at talking about what we're doing. At the same time, I was going through Mass Challenge, which is an accelerator program out of Boston. And so really I was going through these 2 due diligence accelerator programs at the same time, which was really fun in a way. And both the due diligence process that Capital Factory was running, and they were talking to all sorts of people throughout space, and what Mass Challenge mentors were saying is that this first aid stuff, this cyber healing, self-healing is really cool, but how are you gonna go to market with it? It's like, who's gonna want this thing? And how are you gonna explain to them what you're doing? It's like, okay, that's hard. And then I was on a call with one of my mentors one day, and they said, look, can you make something simpler? It's like, yeah, maybe we can make this formal methods thing into a SaaS product. And it's like, there you go, that's it. Because everybody knows how to make something SaaS. It's like, okay, API calls standing up on the internet, we know how to charge for that, go. It's like, all right. So I went back to Capital Factory people doing due diligence, and it's like, aha, that may work. So they didn't quite restart the whole due diligence process, but it's like it allowed them to focus. And both Mass Challenge essentially and Capital Factory said, yes, this is the thing to do. Capital Factory took the due diligence to DARPA. DARPA said, yes, we will fund this. So January 4th, we got a contract for doing that. We used that to sort of invest in doing our sales and marketing, and we were off to the races. So we still, DARPA, the EEI program only pays for that commercialization effort. They don't pay for anything technical. So we still have to fund all the technical stuff ourselves, and which is what we were doing last summer as well. But with the commercialization support, that meant that we actually said, okay, if we put the technical effort in to make a product out of this, there's actually going to be some hope of selling it, because we're technical. We don't know how to do sales and marketing. We can sort of figure it out, but not doing a really good job of it. So that's really the sort of story arc about that. And that's, I have a total of 3 slides here, and then we're going to get into things that are not slides. But that's really what I just described as this one slide. It's like, it took us completing a contract, like March timeframe, February timeframe of 2025, to about the same time frame to get from, hey, you've proven that formal methods can be done in a non-academic format, to actually getting paid something to help turn that into a commercial product. The other thing that happened during this time frame is that all of a sudden, we started hearing that people were in the federal government and the Department of War were interested in self-healing. So it's like, aha, we can now do both. Because formal methods are a very important part of self-healing, because if you're going to use AI for generating patches and avionics and pacemakers and all these mission-critical life safety things, you've got to be very, very certain that when you replace this function with an AI-generated function, that it is functionally equivalent. So we're all for that stuff. If you want to take a picture, that's the sign-up email. It's also my email on there. If you have any questions, just send me an email message. FMT sign up. Rob will get into the second. The only language we support right now is Python, so hope you like Python. Everybody got the picture? I can come back and do this later again once you, I'll wait till Karen's good up. Rob, you got it? All right, so. Just want to start here. Okay. You want to write, you know how to use this? You sure? Maybe. I know, so Rob and I went to Dartmouth together. He graduated a year ahead of me. Both were in the math and then CS program there. He's the one that understands formal methods. Prior to Bernie saying, you use formal methods here, I had no idea what the heck formal methods were all about. So my knowledge has been acquired through reading a lot of what Rob has written about what we're doing, so.
So let me ask a couple questions first, which is, how many of you you're all software engineers of some sort? Yeah? Okay. So one of the things, you know, and that's my background as well, one of the things that you hate, or at least certainly I hate, is writing tests. Right? And I don't want to test my functions, I just write good code and that's it. But the reality is that nobody does, and testing doesn't cover everything, right? If I have two functions that I think are the same because I'm refactoring something, I can write all the tests in the world, but if I miss the test that actually shows that those two functions aren't equivalent, then my test means nothing, right? So the whole idea behind this is that we want to be able to analyze the code for functional equivalence. So if I have two functions and that I can analyze, then I want to be able to show that they're functionally equivalent. That for every set of inputs, they both get the same output. And I'm going to do that in a mathematically provable way. I'm not doing this with testing. And so that's what FMT essentially does, you know, at the the lowest level. And we want to use this in terms of, it's not going to analyze every function. It can't, we know that. But if we can help get a lot of functions, or at least some percentage of critical functions in that we can analyze, we can do all sorts of work to make sure that when you have an AI write something, or an AI work some code, or you're making changes because you're refactoring, that you're not actually changing the operational functionality of your programs. Does that make sense? So
if you're taking the question.
Yeah, go ahead.
I'm a little bit confused about the use case, because if you're getting cyber attack and something's being exploited and you fix it, presumably there isn't some functional equivalence?
So you're touching on something that gets to having a baseline. You need to have, to do formal verification of two functions, you need to have two functions. And you're absolutely right that, and this also applies to a variety of other use cases where you need to refactor something, you need to actually modify the functionality of something, you don't have a baseline. So, and that's what Rob was touching on a minute ago, it's like, we can't apply formal verification to everything, we can only apply formal verification to something. Cyber attacks, you do need to have some sort of reference model. But, if you are the one that built the system that now self-healing is running on, you may have written a formal specification of every function in there, for example. Good, very good. And anybody else, if you have questions.
Does that answer your question?
No, I was generally confused.
Oh, okay. So I mean, what they work best on are functions that, are calculations, financial functions, use cases like that. They're not good at things like AI because it's just, you don't have the right mathematical framework to be able to test things or analyze things. But that's still a chunk of code, and it's for really critical code. So, and that's where we see the biggest use case. And what we do is move that into the CI realm, so that as you're running,
what is CI?
Continuous improvement, or something.
Yes, continuous integration. So one of the things we're looking at is, we originally were thinking about using this as somebody's committing code, you know, so using git commit or something like that, and they wanna check there, it's like, yeah, that's all well and good. But if you are now using AI to go develop code at speed, and their humans are not actually reviewing code or writing the code, then it's gonna be going through some CI/CD pipeline. And so we wanna help make sure that pipeline has got the right gates in it, to make sure that you're not injecting a lot of AI crud into your software development.
And so when you do that, and if you can, you know, if you can analyze the functions and you test them, you can either show that, hey, your baseline was correct, but your new version now has a problem, and we can show you where that counterexample is. You can say that the baseline was incorrect, and now the new version fixes it. Well, you're still going to see a counterexample in there, but it's going to be up to you to decide which one is correct, because our code can't say, hey, your function was correct here and now it's not, or it wasn't correct and now it is. Or maybe they're both the same. They're different implementations of the same function, same behavior, like a refactor, for example. Then that's the place where we can give you confidence, because we can prove that that's true for all inputs. And when we can't prove it's true for all input, we can also take a backup realm and do confidence testing, probabilistic testing, so that we can say, hey, as far as we can tell, if we can find a counterexample, great, that's proof. But if we can't, we can give you some confidence in doing a lot of probabilistic testing that those functions are equivalent to some level. And the other thing we do is that if it turns out that we can't, because it's really inconclusive, either when we try to do the formal methods, we can't come up with a result, and the equivalence testing isn't, doesn't give you anywhere because we run out of time to give you a confident enough answer, that we will report that honestly. We'll say it's inconclusive, and then we want to be honest in what we report. The other piece that we, use case we have for this is in cross-language porting. So if you have a legacy code base and you want to port this over to a new modern language, that you want to be able to make sure that those functions, the old functions, the legacy functions, are functionally equivalent to the new functions that you ported. And part of the problem is that languages are different, right? You have Fortran and you have Python. There's a lot of differences. One has fixed precision integers. The other, Python doesn't. It's arbitrary precision integers. So if you have a function that takes integer parameters, you're never going to be functionally equivalent, because they're going to be numbers that you can pass into your Python function, which you can't pass into your Fortran function, for example. So one of the things we've done is we've added some things called relaxations. These are ways to take the languages and relax the semantic equivalence of them, so that you can compare them. So for example, integer widths, for example, is one. Float precision is another. And we do that, not because we're trying to hide anything, but because when we report a result, we always report what relaxations were used, and you choose the relaxations. Right? You get to choose as the programmer to say, yeah, this is okay. I'm okay if we allow, or if we restrict the integer inputs to being only 32-bit.
This is very much like a compiler flag. So if you say you want to use Fortran S77, for example, then the compiler will enforce via warnings and errors that's the standard doing. Relaxations are sort of our formal methods equivalent of a compiler flag.
And then we also have alignments, and alignments are a little different. They're not where it's not where we're trying to change the semantics of what's happening, but we want to change the structure. Right? So for example, Fortran has functions, parameters that you can pass in, which you can also are returned at the same time, out parameters, or in-out parameters. And you can't represent that in Python directly. So what you have to do is you have to change the structure, a porting convention, if you will, to align the two languages. And if you do that, then you're saying, okay, well, for a function that returns its one of its parameter values as well, or changes its parameter value, we're gonna say in Python, we're gonna allow you to return that parameter as part of your return. And so we account for that when we compare the functions, and we align those two languages. So we can do equivalents like that.
I'm sorry, could you blow up the text a bit? I
Oh,
don't know how to type
or,
something.
I hope. Is that better?
Yeah.
By the way, send me an email, I'll send this to you afterwards.
That'd be amazing, yeah.
We can put it in the Zulip as well.
Okay, yeah.
Okay.
You can also make it full screen.
Okay.
Probably. Do like that. Okay. So, and the other thing, the other piece we looked at with porting is we do an audit of your code base. So if somebody says, hey, I'm interested in, that you're testing our port against our equivalent, or I have this code base, I'm thinking about porting it, how well is your program gonna work? And so we do an audit of a code base, and we walk through and we say, okay, here you have this many functions, and it classifies them into different colors or buckets. And so essentially what we're saying is that we put them into essentially three buckets. Green, which says if this function for a reasonably generated port, say like when an AI does or a human does, but it really needs to be a port. You can't just throw a random function at it. But what that means is that we're likely to be able to formally prove that the port is equivalent, or analyze that the port is equivalent to the original legacy function. Okay?
So like when you're switching languages, so.
When I'm switching languages, so I'm going from, say, Fortran to Python.
Yeah.
Right? So I say, hey, I'm likely to be able to formally prove that your AI-generated port is going to be equivalent or not equivalent to the original Fortran function.
Yeah, that makes sense.
Or yellow, which means that we can't prove it, probably can't prove it formally, but we should be able to demonstrate it probabilistically. We can do some analysis on that. Okay? Red means we can't analyze it for whatever reason. We can't do probabilistic testing because we can't generate the inputs. And then blue is this other category. It's an orthogonal category, which says that, hey, if we ported this thing, we can give you all of these functions as provably equivalent. Okay, so we know our port's going to be provably equivalent. And that's going to include all of the green functions and some of the yellow functions. And what we're saying, and there's a little bit of marketing here too, but we're saying, look, we can do at least as well in terms of provability as an AI port could do, but we can probably do better. Here's the functions we can do better.
So the weird thing, so Rob explained this to me like 3 or 4 times, and all of a sudden I thought to ask him, it's like, wait a second, we can use formal methods to actually port code? And the answer is essentially yes. So.
And so we can do that pre-porting assessment or audit to generate that report. The other piece, and this is something where if oftentimes we talk about formal validation, right? Or function validation or verification. And the question I always ask is, well, what are you validating against? Right? Because I can validate against my previous function that I had that I made a modification to, but if that previous function wasn't accurate, what am I really validating against? So the idea is that we can also write specifications for our functions. So we can then validate against those as well. And our specification language is very straightforward and simple. And the example, one of the examples is here, is that we have, and I don't know, do you have that other report? I'll talk a little bit more about that there because it's a little bit more detailed. But essentially, we can verify against a specification. Of course, you have to write the specification, you gotta be sure the specification is accurate to whatever your domain is, but once you have that, then we can do that as well and have it pass through refactors and so on. And then also we have an audit for being able to walk through CI, code base for use with CI to say, hey, again, these are the functions we're likely to be able to prove formally or verify formally against your previous version. Any questions so far? Yeah.
Are there like mechanisms available to try to make red and yellow functions blue?
I like them. Yes.
I feel like he's gonna talk about that stuff.
I definitely, I will say, parts of this approach does seem similar in some ways to like property-based testing. So, you know, in a sense that's like a different, slightly less formal than the approach that you guys are taking, which is, but it's still in the realm of formal methods, I would say, in that you describe in some kind of terminology what is the property that you want to be true about some piece of code. A lot of times the property-based testing, like Quick Check or something like that, is going to try to generate test cases that demonstrate whether or not this thing is true. It sounds like kind of an approach that y'all are taking is something more in the realm of like property-based testing that sometimes actually involves like proofs. And that's like the point. That's like what you're trying to get across, is that by having property-based testing of that behavior actually be proofs instead of just probabilistic all of the time, which you have available under certain circumstances.
Right, probabilistic is a backup.
Yeah, exactly. Is that kind of an approach that you guys are taking to try to I don't know how many active developers across the Python ecosystem are very familiar with property-based testing, but is that one of the areas that you're like trying to lean into to say like, oh, that's part of who our target audience is people who know what that is, and they're like, oh, we like this, we want the next step, like.
So that's part of the commercialization arc.
Yeah.
So if you're trying to commercialize something, you do what's called initial customer discovery. You try to figure out what use cases people care about, and then you figure out who cares about that use case, and then how much money they have, and all that sort of stuff. And you try to figure out where you should allocate your scarce engineering resources to develop features that somebody's actually going to pay you money for. And so the question is, are the people that care about property-based proofs going to have money to care about our product, or can we somehow communicate with them? And I've got a document, I'll email it to you, I'll make it available to others, about the competitive landscape. And I was looking at some of the people that we think are competitors, and I was trying to understand the language they were using in their marketing materials to understand what exactly they're doing. And one of them, a company called CodeMetal, their most recent materials start talking about what they're doing with formal language-like language, but they started off by doing porting back in 2024, and they're using AI to generate their code and things like that, so I still don't know what they're doing, but they raised $125 million doing whatever they're doing, so they've got something right. And so one of the questions, we went out to dinner last night, one of the questions I asked Charlie, and I wasn't expecting an answer, but it's part of what we're trying to figure out, is like, okay, do we stay as purely in formal methods as possible, just be the company that can just, you know, we've got the formal methods part of this knocked out, and for the chunk of code that falls within the scope of our work, then we're great, but you still need somebody else to help you solve the rest of that scope. Or do we try to go make sure we have a solution to cover like 90% of your code base instead of 25%? But part of the answer is also that I audited 5,000 different Python open source repositories. And so I know how much coverage we have over all of those repositories. So another part of the question is, who cares about what repositories? You know, do you have a code base that aligns well, or are you doing a whole lot of UI stuff and we'll never be able to do anything with it? Fair assessment?
Yeah.
Does that help?
Yeah.
Okay.
I have a quick question, because I'm not a software engineer, right? Well, I'm a founder, and I've been kind of using AI to write some code for me and developing applications. It's been kind of working pretty good, but I've kind of developed a software that an enterprise software where I'm kind of taking like techniques that other companies have, like Google and involving them, right? So I was just wondering, like, based off what you just said, I missed his question, but I wanna know how long I could keep going with maybe just like having Claude or something write my code and then.
I've got an demo that I'll show you towards the end of this, which may help answer that question. So bear with me and we'll get to that.
Perfect.
Yep. You got a question?
Yeah, I was just curious, what constitutes your guys' equivalent-based testing?
I'm sorry, equivalence?
The equivalent-based testing you mentioned, that you do to get a confidence interval between what you guys port over
Oh, the
versus-
probabilistic stuff, it's a whole bunch of different, you know, bounded, unbounded testing.
So
Be a little bit more
the full equivalence
Yeah.
is
Formal method.
formal methods. So
Okay.
if we say these are functionally equivalent, it's because we apply formal methods. Pure.
If we say they're with a confidence of one, that's formal methods. That's purely for.
As a newbie that doesn't really know about formal methods and just here to take it in, is it that you guys just taking the inputs and trying to get
No, so there's
the
no
output
test,
that-
so with formal methods, there's no testing involved, it's a mathematical proof based on the code.
So it means that the two systems aren't capable of behaving in different ways.
For every single input.
So you could test as much as you want, but it would be kind of pointless other than like the first few things. Yeah.
It's a mathematical proof that says for every single input, both of these functions produce the exact same set of outputs. But there's we're not executing anything, we're not testing any of it, it's purely mathematical proofs.
Yeah. I still like the maybe a somewhat simplistic description, but I still like the description when we're talking about proofs. It's like, think of it like the Pythagorean theorem. You don't have to go check a different triangle to figure out if the Pythagorean theorem still holds.
That's why
It doesn't matter which right triangle you look at. It won't ever matter which right triangle you look at. We actually know for sure that they will all have this very specific property. Now, whether or not that property is useful is a very, very important question. Like that property is always going to be true. It's fundamental to the nature of that triangle, of any triangle that has a right angle in it. That said, maybe that's not the thing that you need, and that's one of the things that we run into all the time with formal methods, is that, okay, we have a proof of a particular property of some particular value, but as we were saying, if your code from before was broken in a way that we did not, perhaps we don't yet understand why that was vulnerable before, and now we know that these two pieces of code behave exactly the same way, okay, well then what does that achieve? Now it's able to be exploited the exact same way, unless we modify our assumptions about how they should be doing. And so that, it doesn't solve that problem. You still have to go solve that problem. What happens is, if you solve just that problem, now you're able to use these tools to know for sure whether or not some other program is able to model the behavior that you want, given all of the restrictions you have. And maybe that restriction, you would add a restriction of a particular thing can't be exploited in a particular way or something like that.
Have you tested any, or run like any runtimes or SDKs through your CI stuff? And did you find anything neat when you did this 5,000?
We found a bunch of neat stuff, and there's a lot more neat stuff in there to figure out, and it's a matter of lack of time to go figure that stuff out. And so building that audit tool was internal use, like, okay, how much, we were trying to answer how valuable are we, how much can we really solve? But I could start sort of picking up as like, wait, repositories of this nature tend to be more aligned with what we're doing, but I didn't have the time to dig into it, but it's excellent. bring some money with you and we'll let you go answer the question. Well, actually, so that's, I'm being somewhat flippant, but that's not necessarily, that's inaccurate. You sign up for the alpha program, it gives you access to the audit capability, and then you can go run that against however many repos you want and go answer that question for yourself.
Yeah, what I'm more interested in is like over time, you know, like
So
breaking changes not being recorded,
So we've got.
not bumping the version.
That we dug into a little bit because what I call drift and what Charlie was calling snowball effect, and I'll get into that in a minute. So hold that thought and I'll come back to you.
How, from a practical standpoint, how fast does this run?
Fast.
You know, and computationally intensive? Like,
Nope. It's not, so one of the things to remember here is that we're not using AI.
Okay.
We're not burning tokens, we're not taking up that sort of time.
It sounds like you're not using a model checker is the key there, because like the formal side can get way slower than AI if you start using model checkers, so you're not using a model checker.
So,
And you can also set time bounds, so
Okay.
that's where that inconclusive comes up. If you allocate, a minute, 30 seconds, whatever, to testing something, usually it comes back, it's gonna come back very quickly, but if it doesn't, then it's gonna come back and say, hey, it's inconclusive, I can figure this out in the time you allotted me.
and then you can go allocate more time.
But just to get a relative sense of like, how long would it take to
For
compute?
2 Python
units?
functions under.
It depends on the functions, really.
Well,
But
so-
something straightforward that it can prove easily, then it comes right back.
So for
Second or two.
Like less.
For 5,000 open source Python repos that had hundreds if not thousands of functions, I did all 5,000 of those in like 4 hours.
Okay, and I assume you had to have some sort of like knowledge of the dependencies or the standard library or anything like that?
Not yet.
Okay.
So we're working on dependencies and if we have time, we'll get back to that, so hold that thought.
Okay. But the standard library?
So again, hold that thought. Is that okay?
Yeah,
Good.
So when you're doing, in the CI process, and you're making small changes to your function, you have 2 functions, they're essentially the same structure.
Yeah.
In that case, right? You're not doing a big refactor or anything. And in that case, things like standard library functions are gonna work the same way in both of them, right? So the inputs to them in one function are gonna be the same as the inputs to them in the other function. You can reason on that.
Assuming that the same version of Python.
So
Of course, sure.
So part of where you're going, or where I think you're going, and where I was going and Charlie was going, is like, okay, right now you're just comparing 2 functions, but they have dependencies on other things, which we have not been analyzed.
Yeah.
So to some extent, those are a side effect, because you calling out to it, you don't necessarily know what's going on. So I started symbolic reasoning. Charlie asked me about neurosymbolic reasoning last night. I said, okay, I'll go sit here, and I made a toy problem where it was using Claude to go say, if I can make this function equivalent, well, how do I go to this dependencies? And so what I want to do is if I start with this one code base where only 25% of my code base is amenable to being formally proven, how do I teach Claude to go refactor some of those other functions so that more and more of that code base now becomes in scope? And you were talking about this within repo and outside of repo.
Yeah, so another thing that we can do is we can say, so if you've got an external library where you don't have source code to it, so you don't really know what's happening internally, that we can write specifications for that. If you know what it's supposed to do, you write the specifications for it, and then you reason about your function using that as well. And that's very doable.
Can you speak to also like, what you would need to go through to support a new language, new programming language?
What we would have to go through?
Yeah, like so.
Bunch of work.
Well, I mean, like, what does that work look like?
it's, the biggest part of that work is actually understanding the semantics of the language. And when we do that, after that, it's fairly straightforward. But the hard part is really understanding the semantics and making it so that we can align those semantics, relax the align the two languages, or align, a set of languages together so that we can compare them.
So is it fair to say that the languages, the handful, we don't have a lot of them, the handful of languages where we do have formal semantic definitions would probably be easier to port to? So C, Java to an extent, certainly like the ML families and things like that.
Sure, I mean, depending on the version of C and a lot of the stuff that we're looking at too is if you're porting from legacy C, for example, then you don't have that, and there's still a lot of undefined behavior, and so you've got to handle that properly. And that's part of semantics.
Yeah. So that would be more in the realm of the. I always
when
forget
somebody
the name
wants
of it.
that, they can give us money to do.
I always forget the name of it. It's the project they're working on at Cambridge, where it's like, there was the original comp search stuff where they're trying to get formal verification of C. Well, what they mean is like there is a subset of C that we can use for building avionics for airplanes, which we have. Yeah, like with Fremacy, with CompCert, things like that. And so that's the subset of C that we can have a good understanding of. Okay, so if you wrote all of your C code like that, good for you. Now it's easy to do. And then in the real world, instead we get some C code that came from the early 80s, from some version of Borland that we can't even identify. Like, how did they even get that thing to work? Like, what happened here? If you're lucky, or maybe it's like the Portland compiler, but like it was like a modified, homegrown version of the Portland compiler because someone had a good idea at the office and started playing around with some assembly code.
Oh, you don't even have to go that far back. I mean, where I used to work, they were using Fremacy, and they were trying to get the team to actually write C in such a way that they could verify it. So if only you restructure your functions in this way, we could actually verify more of it.
So, and we do talk about that. We provide a couple of feedbacks with this document. So we have ways of annotating your code that makes it easier to go do full verification.
Yeah, I mean, for example, it may be that your code can't be verified because you have inputs that we can't generate for probabilistic things, doesn't fit into the kinds of inputs we can analyze. But if we know that a part of that function is the pure part, right? That's where the critical part is. That's the part that can be analyzed. You can tag it, begin and end in comments, and be able to say, then we'll look at that function and say, well, we're going to just analyze that piece, and that's what we're going to compare against, because that's the critical part. We don't care if you've got logging functions, outside of that, or print statements, or whatever else. That doesn't matter to us. We just care about that pure piece.
So, are you going to say some more about the secret sauce here, like?
They gotta be a certain level of careful about that.
So we'll say something about it, but so this is part of that commercialization work. So this is literally the very first. This group is really the very first time that there's any public mention of us doing anything with formal methods and trying to commercialize it. We have not said anything anywhere yet. If you look up on DARPA, you can look for our contract and you can figure it out from that. But we haven't spoken about anything. But because Charlie knows Lance and knows other people, it's like, okay, this is a good group of them. So, do you have a high level version of the secret sauce that you want to share? I think of it similar. I'm going to explain in terms similar to compilers in that you start with a high level language, C, Python our case. And then you reduce it to some sort of intermediate language that is well structured and simplifies a lot of other constructs in the high level language. And even a human can do a better job of comparing intermediate language to intermediate language than they can with the high level language. And then there are solvers out there which will then take that further down the stack and say, okay, because we've now reduced this to a language that we, the solvers, understand, we can now say that they're functionally equivalent. There are a variety of solvers out there, there are new solvers coming out all the time. You know, which solver are we using? It doesn't really matter, that's how we go about doing it. There's an enormous amount of other work that goes into it. I mean, I can tell you that what that stack is, and there's still a lot of work to get it right, as we demonstrated. So there's a little bit, a part of our IP protection is we're moving fast. The other one is we filed a patent. Whether that helps us in some way or not, it depends. The filing a patent is mostly about, hey, if we want to go raise money, certain VCs really prefer that you have a patent. And before we run out of time, I'll run you quickly through our pitch deck to show you some of that sort of stuff.
Yeah, we're okay on time.
Yeah. Well, let me take a pause. Let me go show you. If I can get out of this. Yes. That's what I'm doing right now. That's what I'm just looking for.
Just kind of general, when you have mentioned that specification, is that in itself actually some sort of like formal kind of language itself, or some sort of?
A small domain-specific language that we set up. And something that's, you know, and a lot of this too is that, you know, I get a lot of programmers hate math, right? And so the more we can keep it simple and not, you know, that is very accessible and something in their sort of context, the more likely they are to use it.
So this is a simple text-based demo script. And a bunch of AI done in this, so some of the language is very like aspirational and like believe in me, so just bear with me. But Charlie said last night, hey, neurosymbolic.
Yeah, neurosymbolic stuff, yeah.
It's like, if you can do that, you know, people will pay attention. It's like, all right, let's go do that. So I've got two different demos of this, and this will also show a little bit more about what the concepts are. Normally I've got two panes open, I can show you the actual original source code. Because of screens, I can't do that as much. So we have a small Python library called mathlib. It's got a bunch of modules in it. And before we let the AI loose on it, we use that audit capability to map out what the tree looks like. This is not running locally, this is actually making block calls via the API.
Is this the mathlib?
No.
Yeah,
This is our mathlib.
yeah, not the lean mathlib, yeah.
Yeah, no, we'll rewrite that next week.
There are people doing neurosymbolic stuff. In fact, that's stuff we were doing earlier. The harmonic stuff, they are using neurosymbolic loops on mathlib itself. That is a monstrously expensive computational problem to be working on. And it is not yet, as one of the common themes that came up at this most recent NASA Formal Methods conference, is that a lot of the neurosymbolic stuff that people are demonstrating up till now has all been in the realm of mathematics, because we now have mathlib and lean, and it's so sexy. Look, we're doing new math. Nobody has done this math before. Isn't that great? And it is great, and it's really cool, and it's gonna be a neat thing to see going forward. What it isn't necessarily is useful computer science stuff, because it turns out that the types of proofs we're finding, even the formal proofs that we have in the math world, aren't necessarily solving the same problem as computer science. In the same way, it's not surprising that computer science is not solving math problems. It turns out that math is not solving computer science problems. And so the problems that we run into on the computer science side, they involve like ambiguity of what are valuable properties to have. That's usually not the problem in the math world. Like, we also have problems of the logic inside of our computer science related proofs tends to not be, it doesn't tend to be really complicated logic. It's really tedious a lot of times, but it's not very in-depth complicated logic. That is the problem on the math side is that, like, the structure of the proofs themselves can be monsters. The only problem with the computer science-based proofs, when you're trying to make a program proof or something, you usually don't have some extremely sophisticated logical basis. You probably have one or two very simple logical systems, which you know, beat to death with lots and lots and lots of theorems and proofs of potentially useful properties, all the way to the point where it no longer makes any sense anymore because you've abused the abstractions too much. Now you have to start over with a new set with new abstractions. It's like the things that you're proving aren't hard in a certain sense, from a math sense. They are really tedious, and sometimes they're not reachable by the same construct. In math, when something isn't reachable by the same construct, you fail, and you start over, and you have to go back to the drawing board. With computer science, a lot of times, we're fine with that. Like, if somebody came up with some system, and they're like, yeah, we'd really like to have one proof just in lean. But it turns out, this part of the system, this part where we're like reading user input, that's really easy to verify with lean. And this other part, where we're performing these complicated calculations, for some reason that's easy to do with Isabelle. Well, the end result is probably okay. Like, everyone's okay with that. They're like, oh, yeah, it would be better if it was all lean, or all Isabelle, or all rock, or something like that. But maybe we're okay with the idea that parts of it are in different systems, even if we don't know for sure. You know, in one day, we're going to get to a point where those distinctions do matter, where you're working on a problem, where the distinctions between what defines truth in lean and what defines truth in Isabelle are different enough that it's important. It's one of those things that we were running into when we were talking about the lambda calculus, is it turns out these fundamental details about the pure logic, or when we were talking about the assembly type lambda calculus as well, is when you're looking at just the logical constructs and you start putting them together, sometimes, like, they're fundamentally incompatible in ways that are meaningful.
Right.
And so that's yeah, a bit of a tangent.
Helpful. So what the audit does is it says for the 25 functions, you know, 15 of them are formally verifiable, 6 are high confidence, 1 is achievable with annotation, 1 is achievable by modification, and 2 are out of scope. So now, from a, hey, we want to tell our agent what functions to go focus on, we now know which functions to go worry about. Don't worry about the ones that are out of scope. It doesn't really matter. So it takes a look through the ones that are formally verifiable, and it says, hey, a RIF is even, and what it says is it wants to collapse the if else, and normally this is where you have the other code in another window, and it's just not big enough. So just trust me that there's code in another window, and it's going to reduce that code to a simple Boolean. It looks equivalent to us. We ask FMT, FMT runs, the before is that line, and that's what it collapses to, they're formally equivalent. And it also says, hey, I just re-audited the rest of the code base, nothing else changed while I was doing this. So, proof. So same AI assistant, now we're looking at the average function, computes an average, the assistant proposes distributing it, the divide, looks reasonable, see what happens. So it turns out that the before, this is what it was, this is how I rewrote it, and it's not equivalent, and it provides the counterexample. So that's a demonstration of, we're not just telling you when it's equivalent or not equivalent. In this case, we are able to tell you it's not equivalent, and here's the inputs that you can use to go validate that for yourself.
Yeah.
And you gave a thumbs up, because that is the important part.
Yeah.
So code base, and now what's happened here is that a whole bunch of commits has happened, and you're not sure where a breaking change came in. So this is, again, the audit function is looking for breaking changes, it's walking through all the commit history, and it says, okay, at this point, there was a commit on the clamp function, and The intentional is that the LLM or the human said, I'm submitting a break and change, I know it's a break and change, and that's now your new baseline. You have the human or the LLM, if you trust it, has said, I wanna go make these two functions not functionally equivalent, I'm committing a new one. That new one is now your truth, it's now your baseline. It may be wrong, we can't tell you which one of those functions was right or wrong. All we can tell you is these are functionally equivalent or they're not with examples. So, that's one.
Very nice.
So, same setup, mapped everything out. A little bit more detail, so formally verifiable tells you which ones are, which are high confidence, blah. So now what we're doing is we're starting to move up the food chain in terms of asking Claude to do more work for us. We now want to give it guidelines in terms of, hey, go look at this code base and refactor or somehow go modify certain functions in this code base to be better by some measure. So in this case, there's Euclidean algorithm in here, and we wanted to make a better version. This is the problem with doing live.
Yeah.
API key is valid.
The API key is invalid, and I'm just trying to think why that would have happened between the last time I ran it and now. I'm just gonna have to let it go.
Yeah.
So, okay. That's just gonna keep me up failing. So, I apologize for that, that's your classic live demo.
Demo gods.
Demo gods.
Very, very generous so far.
That was happening this afternoon, and it was just because I was mucking around with things, so.
Yeah.
One of the pieces that I think should be pointed out, I mean, obviously these are examples that you can look at and say, oh yeah, these two things are obviously. Let me show you one where it might not be so obvious. I can't.
Which one do you need?
The calendar one?
Do you remember which document that was in? Yeah, good luck. You wrote it today?
Yeah.
Is that the only one you sent me? Oh, I know where it is. Okay, ignore, and this is going on a live video. So, language reference?
No.
This one.
Second specification.
Don't not maps at the same time. It's fine. This one? There's the calendar right there.
What was right after that?
That one?
Updated. That one.
Oh, this is, I do have it here. This one, yeah.
Okay. So let me give you the overview here. So let's say you needed to write, and I know you would just use a library for this, but let's say you had to write from scratch. The idea of being able to take two calendar dates, month, day, year, and find the number of days between them, right?
I'm working on that with Isabel right now.
Right, and it seems pretty straightforward, but the problem is, how do you prove that what you have is correct? So, one way to do it is to say, okay, I'm gonna assign a day number to each date, right? And then I'll subtract those two day numbers, and that'll tell me how many days are between those two dates. So, you can go out on the internet and find functions like this. Here's one of them, right? Returns a number uniquely identifying the state, right? It looks at the month, changes the month, and then does some calculations with a lot of divides, integer divisions, it looks like, and multiplications, and I have no idea what the heck it's doing or what kind of number it's going to give you. But then the rest of it's pretty straightforward, right? Days between dates takes six numbers, 6 integers, month, day, year of both dates, and calls day number on both of them and subtracts. And then we have some helper functions, right? Is something a leap year? Is, how many days are there in a particular month? Is there is the date valid? Because we need to know that. And then what's the next date, right? So how do you know it's correct? You can write lots of tests, right? How many? 3 million valid dates at least in a reasonable range, and you can't test them all. So what do you do? So one way to do it is to look at writing a specification for this and looking at and using that specification with the implementation to actually prove that your code is correct. Right? And so you have to give it some domain knowledge, right? So you have to be able to say that is leap year, right? That's the function, whatever it is, up above, where I define what is leap year is this. This is the specification for what a leap year is. And can I prove that that's correct? No, that's my domain knowledge. You can look at it, you can assert it's correct, or you can say, nope, I found a bug, and that will change things. But I'm pretty sure that was correct. For the number of days in a month, pretty sure that that's correct too. I can show that if the month is the second month, it doesn't, and the year is Y, that there are 29 days if and only if there's Y is a leap year. Okay? Otherwise, there's 28. Otherwise, there's 31 if, that old song, 30 days past September, all of that there's 30 in April, June, September, and November, and 31 for all the rest. Okay? You can look at the valid date and say, if D is a date made up of a month, day, year, that we can look and say the month has to be between 1 and 12. You know they're integers. That the days that are between 1 and the number of days in the month for that year, and that the year has to be greater than 1. Or, look at positive years. And then we say, well, what does it mean for a valid date and next date? Well, we're saying that we want to show that if D is a valid date, and I'm looking at this here, right, and the number of days is less than the number of days in the month, that the next date, basically, I add 1 to the number, the day of the month, and I keep the same year. Okay? If the date is valid and the number of days is equal to the number of the days in the month, and the month is less than 12, then I have to bump the month up also. And if it turns out that the month is 12, then I bump up the year and go back to January 1st. And that's all that says for those proofs. And now, here's the key for the whole thing. That if I have a valid date, that the number of, that implies, so for whatever, no matter what date it is, as long as it's valid, that implies that the number of days between the dates of that date and the next date has to be 1. Right? And that's all I need. Do I care what that weird function, day number was? No, because if I can't prove this, if this isn't correct, my day number can't be correct either. And that's a really powerful statement, because now I've just proven something about my code, and that my domain is correct. The days between dates is correct, because that's what I care about. Right? But I've also proven something about this function that I have no idea how to analyze. I don't really know what it does, but if it does it right, this will be accurate.
So this one little correction, you're saying will make the whole entire system basically completely 100% accurate.
Right, so if I can put this specification in and run FMT on my code with this specification, against the specification, I can show that my code is correct.
Correct. So basically to answer my question kind of like earlier, this would be kind of like a method to, I guess, like kind of check my code, train my code, or?
It's a method to say what you want your code to do formally, and then prove your code does this.
No matter what language you write it in.
Yep.
Whether it's Python, okay.
Python, C, whatever.
Or if AI spit it out, whatever, it doesn't matter. If it matches that, if that comes back clean, you're good to go.
And so
Whatever it is.
this sort of goes back to the question at the very start of the hour about it's a cyber attack. You don't know what the original code was.
Exactly.
If you wrote a specification for whatever your pacemaker firmware is for every function in there, if something modifies that code, malware or something like that, you've got the specification, you can rewrite that, and not only you ported it to some other, architecture, you can rewrite it without the source code for whatever architecture in whatever language you need.
And is it because of the specification is kind of making the architecture? Or is it?
It is enough information to know whether or not the architecture you get is good. That's it.
And so the other thing is, I mean, this is not it wouldn't happen here, but let's say somebody wanted to put a back door in your code by modifying that complex function, right? And they do it in such a way, because you're never gonna know, you're gonna say, oh, I optimize this to make it faster, right?
Yeah,
And there are ways to do that, there are other
There are use
functions.
cases where that happened recently.
Right,
Yeah,
right,
yeah.
right. And
Or,
so-
or your AI said it refactored and it dropped
What got it wrong,
Yeah,
right?
it just screwed it up, which is much more often, like.
Which
run
you,
it-
and Steve,
Yeah.
you had a question?
Oh, yeah, so you mentioned that you would have to write tests for these couple functions that you presented earlier on that premise, but then following that, you say you have a FMT where you're doing formal method testing, you have a spec that you've created, and you're running that on a sample?
I'm not
input, or are you
running
that
any
on-
code, what I'm doing is I'm taking the code that's here and the specification and comparing them to make sure that they're the same.
Can I take a tangent?
I guess I'm confused, how is that different from writing
So-
tests on?
So hang on, that's where I was just about to go. So, I've been a software engineer on and off for most of my life. And I've been told to go look at some existing code base, and if I change anything, run it through the QA tests, and if it clears all those QA tests, it's good to go. Almost every single one of those QA tests was written because something broke. It's like, oh, this broke, let's go write a QA test for that particular use case where this broke, and add it to this whole slew of now hundreds of tests to make sure that now our code is correct. You don't know that it's correct, you just know that it's not going to trigger any one of those tests that you already wrote. What this is doing, and Rob will correct me if I don't get the language quite right, because he's much better at this than I am.
Okay.
What this is doing is that you've written a specification to say no matter what language you've written in it or how complicated you've written it, the code must meet these requirements. When you give it this, you need to get this back out. It's not testing for edge cases or weird user input or like that. It's testing to make sure that your code does exactly this.
Now, to be fair, you have to write the specification, right? You have to understand what you're writing and,
Sure,
and
yeah.
what you're working in. But if you can do that, that's a very powerful tool because you never have to write a test case for this.
And particularly with mission critical systems, life safety, things like that, you don't have to write a spec. I mean, ideally you write a spec for everything, but you don't have to write a spec for everything. There's a certain amount of the core functionality, like this has gotta work right every single time.
So is it like a universal specification basically?
Not
Yeah, so the idea is that the specification always applies no matter what the inputs are, and that's the idea. So by describing it at this abstract layer, instead of saying, can you tell me how to add? I mean, it's like, well, okay, if you add 1 and 1, that's 2. It's like, okay, what are the other things that you can add? And you could be listing out numbers all day long for the rest of your life, and you still won't get all of them. But instead, if you have a specification for how does the add function work, it's more complicated than just listing off what is 1 plus 1, what is 1 plus 2, what is 1 plus 3, forever. But while it is more complicated to do it, you actually have more confidence that the thing is right when you're done. Because you now have described the entire behavior, and not just a whole lot of examples. One of the things that always comes up with testing is when dealing with calculations and such, is what do you do about buffer overflows and things like that, or integer overflows or whatever. It's like there are all these edge cases which most developers wouldn't even think to check for. There's always going to be some other thing you didn't think to check for. By having a formal specification here, it doesn't mean that you're not going to have any problems. It just means that the behavior of the system is exactly the way that you think it is from the perspective of what you've described.
There's also a couple of, and I'm not forgetting you all, just bear with me just 1 second. So I can sit down and explain this specification. My wife has a PhD in English. She's absolutely brilliant. She doesn't do math or engineering at all. I can sit down and explain this specification to her and she gets it.
Yeah.
However,
That code.
that code only makes some sense to somebody who knows that particular language, and even then they may not know it. And it may have been written by somebody who, anyhow. Or if that's malware and it's intentionally obfuscated, you're really not gonna understand it, so.
Yeah, and how do you know if it handles things like integer overflows, integer underflows? What happens if you put in negative numbers, things like that? Those are the kinds of things that get automatically pop up when you're trying to make a proof. They're not the kinds of things that a developer will think to try. Well, what happens if I check to see what's the distance between yesterday and tacos? And it's like, okay, tacos is not, Taco Tuesday may be a thing, but tacos is not the name of the day.
Right, and to go to your point, so.
It's Taco Tuesday.
But would they bring
Yeah.
that up too, though? I was gonna say that.
Right, so let's say you wrote the implementation incorrectly, right?
Yeah.
That somebody wrote it and missed the century year, right? Cause
Yeah.
a leap year is a leap year if it's divisible by 4, but then if it's, what is it?
But not if it's 100, but not if it's 400.
Right.
Yeah.
Okay, so if that's the case, then when you run FMT on this against your specification, it finds that, it looks at the specification and says, wait a minute, y equals 100 means that his leap year returns true, but the specification says it returns false. Therefore,
And that'll produce that, we know for this input, it's.
Yeah.
right. And then what it will also do is show that, okay, so we've got that, so now let's find a true counter, a real counterexample for month, day, year, and we can do that as well.
Yeah, so there's still value in doing tests even when you have proofs, but what you're not doing is lots of tests. You're doing like a few basic tests to be like, am I even in the ballpark?
But there's no tests going on.
Yeah, yeah.
Right, it's not running any code.
It's not running any code. You as a developer might still do a few tests just to see. If
I might still say, okay, do I believe you? Let me test it and see
Yeah,
what your
exactly.
counterexample is, and that's not a bad thing either.
Yeah.
And in fact, FMT does that as well. If it gets a counterexample, it will actually test it to make sure it is a counterexample and not just rely on data, even though it should.
What's really funny about this example is your wife might be able to correct your implementation. Cause
Yeah.
there's no like Gregorian, you know, when they set the time forward by a week or whatever.
Right, we're
So-
waving hands a little bit.
But what's
here,
kinda
though.
neat is like someone who's less technical or a novice programmer can find flaws in the logic. That's, you know, just a comment to him. Like,
Well, one of the things I think is very valuable as well is in the same way that we were saying, you know, not every developer will even know what the heck they're looking at with the giant pile of calculations in the Python specific format there. But even NASA is a good example of this, where they have serious world experts at a lot of things. And some of them are even experts in various programming languages. Not necessarily the programming language for the system that they're going to put up into space, you know? And so they're like, I know that when, you know, this sensor looks like this, and then this sensor looks like this, and it's been this amount of time that this rocket needs to fire, or this, you know, correction angle needs to be set, or something like that. So they are experts in that regard. They're not gonna be able to go in here and inspect your Python code or whatever code. They know how to describe what they're talking about. And so then the idea is if you can make a specification just that encapsulates what it is that they're saying, even if the developer doesn't understand the specification, the tooling can automatically go and check.
The logic.
Yep.
Yeah, so, again, this might be part of the secret, so also, I'm curious to know about your specification language. What do you use? Is it, like, Untitled Chapter? Or, like, what do you use?
Yeah, so, 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 so,
like in particular, are you restricting yourselves to like just, input-output functions? Are you doing reactive systems, and you take temporal specifications, and what else?
Not doing anything temporally, you know, it's pretty much, right now, this is pretty rudimentary, right? But it's still very powerful in terms of what it does. We can, you know, plans are to expand that as well, you know, as we need to, but that's,
So
yeah, go ahead.
That's part of that commercialization work.
Yeah.
It's like, we're working on the things that we believe are important, and that of the first people we've shown this to believe is important. Part of the reason for making this available to you all is like, you may say, hey, this other thing is really important, have you considered doing this? We'll go figure out, okay, do other people care about this problem? If they do, we will prioritize it, that sort of thing. So that's basically, the actual function, the actual capability around proving formal equivalence for Python is about as rock solid as we can make it. We've put a lot of time and effort into making sure that works. There's a lot of other things which we've done just enough on to show, here's how this thing would work, if somebody cared enough about it to pay to get it done. We can't afford to go spend a month building out the specification if somebody's really waiting for us to go do that other thing. And that's that commercialization story. And I'll go dive into that for a little bit. Let me make sure I got all the questions for this section. Sure.
Do you think there's still some, I guess, commercialization avenues for the DSL around specification, like further work against it, or is it something you feel is kind of in a state that's
there's still space? Yeah. My answer on almost any of this is there's still space. I've looked at our competition pretty closely, and even the company that got $125 million is still trying to figure out some of this stuff. It's just, there's a lot of work to be done. Good.
Yeah.
So just curious, when you said you had 50,000 functions analyzed in like 4 hours that you did the porting over, so does the agent create specs from the domain functions and like iterates on that?
Yeah, no, so when he did that, he wasn't creating specs, he was just looking at the functions for, you know, analyzability. How much could FMT?
I was seeing which buckets each one of the functions in each one of those repos fell into. So I was trying to figure out.
Okay, but you didn't run the equivalency. Okay.
No.
Okay.
I determined whether they could be whether we could apply formal equivalence to them. I did that much.
And one of the tests that it also does is it gives an estimate of whether it can prove the formal equivalence within a constrained time.
So just curious, is that where you got the functions that are out of scope then? Like when you get those labels, or is it?
For every single one of those repos, the audit function said for each one of the functions in each one of these repos, which bucket they went into.
Okay, and what is the criteria for getting it labeled as out of scope?
Out of scope if it's you know, we don't handle async calls, for example, in Python. So that would make that function
just
out
the
of scope.
function type, you don't handle async.
So it could be the kinds of inputs that go into, if we can't model those inputs, then we can't reason about them on a formal methods approach, or we can't do probabilistic testing because we can't generate inputs.
It's just opening up a shell and it starts dumping out code in a different programming language, and then just like, execute that. It's like, well, in some sense that's Python, but in some sense it's not.
So I guess those are discrete kind of maps that you guys have a corpus on of what would fall into this bucket.
Yes.
And then skip those or like label it as such. Okay, makes sense.
So I'm going to take a quick pass through the competition. I'm not going to share this out to everybody because but it's going to give you a sense of what else is out there. Axiom Math trains LLMs to emit lean proofs, so it's similar to what we were looking at earlier. Code Metal, the Y says AI powered legacy code migration platform. That's what they were doing in 2024. Their language that I've seen, there's a Wired article about them if you want to go look them up. their language looks a lot more like they're using formal methods, but are they really using formal methods, or are they just using that language because it'll get people to give them money? I don't know. Diff Blue, they're doing unit tests for specific languages, and then there's a whole bunch of other ones in here. If you've ever had to do a
Harmonic, wasn't it?
It was Harmonic, isn't it?
Yeah. Oh, and so is the.
Oh, I sent it to you, yeah.
In Montrose across the street here.
Yep, Harmonica, IBM Watson, so there's a bunch of people that, there's the classic quad chart. If you've ever had to do a VC pitch, there's your quad chart.
Yeah.
So there's that. And then I'm going to show you our pitch deck, and then we can dig into whatever we want. But this is for people who care about a, we need to raise money type of thing. Sorry. So, Capital Factory did a DARPA First Money pitch event, what, a month and a half ago? 6 weeks ago? So this is what we did for us. I'm gonna go through this at high speed, I'm not actually pitching you all. We needed to have a tagline, we need to have something that would get people's interest, we needed to say something like, wait, what are these people talking about, and get them out of their phones. So that's what we did. The Boeing crashes were based on software flaws. And so what our hypothesis, what our messaging is that what we were talking about earlier, your unit test only covers some of the inputs. What formal methods does for the things that are in scope covers all the inputs and outputs. So you've got to be aspirational. What are you doing? Why is this valuable to me? What we're doing is we're selling certainty to people that cannot afford uncertainty. Medical, life safety, aviation, things like that. And we're trying to get across to people that this is relatively easy to implement. It's not going to take you 2 months to implement it. You can drop it into your existing CI/CD pipeline, no new tooling. It's all SaaS. You know how to do that sort of stuff. This is really talking about how much people are using AI for going out and developing code. And it's hard to go look at any sort of media these days and find somebody's not talking about, hey, we're now getting rid of our engineers and we're going all in on AI. And so we went off and did a fair bit of research in terms of how much people are using AI and trying to get data to support that. So it's not just me saying this is what's going on, here's a citation to go support it. How many more defects this is creating, and the fact that if you go interview, and we did interview a bunch of people in senior leadership positions in some of these companies, just because AI is generating code doesn't mean they're more confident in the quality of code coming out. And there's an argument to be said that they're less confident in the quality of code coming out. And so that's the problems that we're trying to solve. This is what we're doing. If you provide 2 implementations of the same function, original versus refactored, human written versus AI, before patch versus after, we will construct a formal proof of functional equivalence verified across the entire input space using, I said SMT solver, sorry. Rob was like, don't say these things. That's not true. And you receive a deterministic result if it fit. Go to market, how do you go to market? You gotta have a pricing model. This is what we came up with. And if you've ever done pitch decks, you try to figure out how much money you need to go do certain things, and then you sort of work back. You do some research in terms of what people are paying for something similar and things like that. The 2 ways that we thought about doing it for enterprise, it's a per seat, plus a certain amount of money per API call. And then for individual engineers, there's a freemium model essentially. So a lot of people are familiar with that. We need to bring it home for people. If we're trying to raise money, we say, okay, who's gonna care, why they're gonna care. So engineering VPs, and that's what this column is. People, the champions, the people that we want to connect with that are going to care about the problems. People doing just standard engineering, modernization, compliance, and then this column is getting into, hey, how are they going to pay for it? And in many of those cases, for each one of these people, they already have a budget line item that's going to cover it. It's already part of their software development budget in some way or shape or form. And so the message we're trying to get across to them is that you don't have to go back up to senior leadership to go ask for another couple $1 million. You've already got that money allocated in your budgets. The market didn't exist 2 to 3 years ago. We were barely getting decent code out of LLMs a year ago. And so this is really, TAM stands for total addressable market. That's in sort of raising money speak. That's like, if you could solve everybody's problem who has this problem, how much money would you get? 27 million. All right, you can't go solve everybody's problem. So let's break it down. Now you're starting to say, okay, what can we do in a more targeted market? And so for anybody who's doing AI-assisted development and compliance-sensitive verticals, we could probably get $500 million a year in revenue. And so let's break that down a lot more for our first year, second year, third year. And this is our third year target. Our annual revenue would be $25 million per year at the end of 3 years. That's us. This is what we're asking. Standard pitch deck, and then how we're thinking about things. So, for those of you who are running startup companies and who are thinking about doing something esoteric, that's kind of what your pitch deck looks like. It's based on Guy Kawasaki's, 10 slides you need. That was actually more like 12, but it's still got that sort of focus. So, sorry.
So could you say a little bit about how you got to this point? Because I thought I saw something in the slide that was talking about SBIRs and things like this.
Yes. So, small business, SBIR stands for Small Business Innovative Research, if I remember correctly. The big picture is that every single US government agency is required by law and is run by the Small Business Administration to put a certain amount of their budget into the SBIR program. And I'm going to do this at a very high level, and there's a lot of nuance to it, but fundamentally what the SBIR program is that 3 to 4 times a year there's an announcement by every single one of those agencies saying, this is what we'll fund. And there's SBIR phase 1, SBIR phase 2, SBIR phase 3. SBIR phase 1 is usually like you've got a back of the napkin idea, and you want somewhere between $75,000 and $150,000 over 3 to 6 months to turn your back of the napkin into something that you can show sort of working as a proof of concept. It's like, great. SBIR phase 2 basically requires that you've done a SBIR phase 1 or SBIR phase 1 equivalent, and it's usually somewhere between 15 months and 18 months to 24 months in period of performance, and somewhere between anywhere from 150,000 to we've done to $1.8 million SBIR phase 2s. And what those are designed to do is to take this thing that you said, shown that works in a lab environment, and get it to just below being commercially viable. And there's a lot of rigor in there. If you're not spending the money wisely, they're going to cut it off earlier rather than later and things like that. The problem with SBIR programs, there are a lot of problems with SBIR programs. But the problem from a performer's perspective for a SBIR program is that there's all this support to get you up to what's called TRL 6, Technical Readiness Level 6. But there's very, very little support for getting you from the, we proved this thing, it's ready to become a product, to getting you from there over to something that's commercially viable. The exception in my experience, I've done work for the US Air Force and worked with a bunch of the other agencies, DARPA has commercialization, I call it, what's the name of the office?
Commercial Strategy Office.
Commercial Strategy Office, and they also have a commercialization and transition program within that. They have a group of people that exist solely to help certain DARPA performers get from TRL 6, SBIR phase 2 into a commercial product. The beauty of SBIR money is that it doesn't have any equity. As long as you meet your contractual requirements, they will give you the money, and there's some exceptions to it. So it's great, but it takes you, from the time you write the proposal to the time you're actually under contract is somewhere around 9 months to a year. So it's not going to happen quickly. There's no guarantee you're going to get the proposal. So you wrote something, you're counting on getting the money, and then you don't get awarded a contract, now you should not have made those plans. It also means that once you accept the so during that 9 months, if you take or let's say you get under contract for 2 years, and 6 months into that, you realize that you're going in the wrong direction, you still have to finish that contract. And that may take resources away from what you really want to be doing. So, in general, it's positive, but it's not all sunshine.
Is it really competitive to get
It's
phase one?
deeply competitive.
Mm-hmm.
I have personally written 4 Cyber phase 1s that won, and now 2 Cyber phase 2s. I've written probably about another 20 Cyber phase 1s that didn't get that, and you don't know why. That's one of the big problems. You write all these proposals, and they just say you didn't get it. It's like, can you tell me why I didn't get it? Because then I can do a better job next time. I can go on about Cyber programs for hours, so don't get me started. But it's a good way, promoting capital factory and things like that. So I live just north of Boston. I've been through multiple tech accelerators. I've not been through capital factories, but in terms of tech ecosystem, you all have a wonderful ecosystem here. Boston, we have centers of excellence scattered all over like 100 square miles, and so getting from one to another is hard, and you get to this fragmented system. Every time I come down here, I can meet people from different parts of the ecosystem just by staying in Capital Factory for a couple days. Or going to one of the local bars and things like that. And you've got defense, you've got commercial, you've got healthcare, you've got all this stuff in one spot, and it's just a phenomenal resource.
It is, I'm not gonna lie.
It's great. And you've got, I mean, there is not a formal methods meetup group in Boston. It's like, how do I find the people doing formal methods in Boston? I don't know, but I can fly to Austin and here you all are.
As far as I can tell, we're still the only one.
And this, everybody, I'm pretty sure like everything we all need is literally in this room right now. You know what I'm saying, from each other, like what do we need from another person? Someone has it, you know what I'm saying, so you're definitely right.
Well, none of us are attorneys though.
And that's one, and so this is one of the things I always try to encourage, and I help each other out. I've been through multiple accelerators, 2 of the 3 of them started with the premise, and they said, you all are, we selected you all because you all care about this particular set of issues, but none of you are in competition with each other, so you should all be motivated to help each other out. It didn't happen. It was very deeply frustrating because I tend to be idealistic, I tend to want to help other people out. There was a 3rd accelerator which was not as bad as that. I strongly, strongly encourage you to help each other out. It will pay dividends somewhere down the road. It may be that you help them out and your company fails out and 3 years later you're looking for a job, you get another idea, and it's like the people you helped out 3 years ago, you know, made $100 million and now they're trying to help other people out and they still are. Help each other out, go to meetups, go talk to everybody, be really supportive. That is deeply important. You are helping us out today just by being here and being willing to listen. And I want to thank you deeply, because this was a forcing function for us. This forced us to start putting together some materials like, okay, we now have to explain this stuff. And we didn't do a 100% perfect job.
You did amazing,
Thank you. We appreciate that, but we can do better, but you forced us to at least get started on doing this. And another part of the commercialization effort is like, Rob and I have he's been doing all the engineering, I've been writing QA, I've been doing the audit stuff. It's like, oh wait, we have to make this available to somebody. We need a customer management portal. I need to be able to issue API keys, including to myself apparently. And I need to be able to rotate them, and I need to be able to bill for them and all that. It's like, so I've spent the last 3 weeks writing a customer management portal. It's just, you never know what you need to do, but having events like this are a really good forcing function for, let's rip the Band-Aid off, let's get it out in front of people and see what happens. And I really want to thank you all for being here, for asking some really good questions, including questions that we didn't really want to answer, and I apologize for that.
I was expecting that.
Yeah. But no, I appreciate you asking. You can go, you can't see our patent, it's not, anyhow.
Eventually.
Eventually.
We'll post it in Zillow, but.
Yeah. No, just really thank you very much. you've got, my email address.
Can you put that on the screen one more time so I can have you use your emails?
It will go up in whatever you call Zillow.
Do it, yeah, yeah.
Do it. So, one second.
I just wanna make sure. And I think I do have it, but still, let me.
Yeah, the whole stack works. Python's very well supported. To somebody's questioning what languages are we to support, that's a very good question next. One of the things that we're doing right now is we're going back, and as I said, you know, the Python implementation is rock solid. We're going back and making sure that implementation is rock solid. And as part of that process, we're going back, and making sure that everything's written and structured and architected in the right manner to make adding more languages faster, smoother, less error prone. So if you'd asked, if we had started trying to support C 2 months ago, I'm taking numbers out of my head, it would have taken us a month to go get it up and running well. If you'd asked us that to do it about a month ago, it would have taken us 3 weeks. I don't know how long it's gonna take next time, but it's gonna be much smoother and much faster because we're going back and doing the due diligence to make sure things are solid. Any questions? Next.
Awesome. Well, thank you for coming out. Very much appreciate it. I think this has been a great first guest speaker. I think we've hit the jackpot here.
Yeah,
so as again a reminder, before we forget, if anybody needs parking passes, I strongly recommend you get this. It makes it $8 to park here instead of like $50. So I would strongly recommend you get one of those if you park here. We've got stickers. We've got more stickers if you need more stickers. As I mentioned at the beginning, next month we are not going to be able to meet here. Capital Factory is doing their once a year internal thing, so we're going to be meeting at Diogenes instead. We'll put the information up on the Meetup page. And starting in a couple of weeks, we're going to try this every second Sunday thing, where we're going to meet up at the venue on Highland area.
That's right by my house. Yeah, that's right by my house.
Oh, nice. Yeah. And so we'll be up there for a couple hours in the afternoon, and then just see if we can make some good progress on that stuff. And I forgot to mention at the beginning, next year, NASA Formal Methods will be in Houston. So start planning now. Every time we've had it in Houston, we've had a group of people come from Austin to go down there to see it. It's free because it's NASA official. So you just have to register ahead of time to let them know you're coming. They used to make you do an FBI background check, but no. Well, when they do, sometimes they have done it at NASA facilities, like behind closed doors, and so you get to see really cool stuff.
Do you have to do like polygraph and stuff?
No. It's not the kind where they come and interview you. It's the kind where they trigger one on the back end. But they haven't done that in a while, which makes me think maybe they're just not doing it anymore. So.
Do you get back a report of like what they have?
Nope. You say.
Well, what if they have some incorrect information?
Well, then you would just contact them or whatever. No, you would basically just give them. Back when they used to actually require the FBI reports, you just give them your name whenever you sign up, which is why the sign up is like 3 months in advance, and you can't just walk up on day of.
When is that?
But it'll be
I've got some
next
cards
spring.
here if anybody.
So.
Oh yeah.
Okay. So, anyways, I don't think they're gonna be doing the FBI thing anymore, but we are definitely gonna have a carpool go down there and enjoying the festivities. So.
Is this usable?
Yeah, it's usable. Yeah.
Because you're gonna scan it and then you pay the rest.
Yeah.
Okay. Reusable.
Reusable is not reusable.
Okay.
Like each one has like a different code, so if you look at the numbers, they're all different for each one.
You already reverse engineered and figured out how to get free parking.
Oh yeah.
Or discounted parking.
Who are you talking to? You know the answer to that.
Thank you.
The answer is yes.
Thank you very much.
Well, so there's actually have an answer that completely
Yeah,
different
question
you
you
want
want
to
to
take.
take
So I'm going to like one of those events and I want to make sure that like in case that one doesn't work, that I have like a backup or whatever.
Yeah.
I live in Maryland, but we went to school together a long time ago, so.
Okay. Thanks for working on it.
Okay, yeah.
Thanks, Charlie.
No, I
How you doing?
spent a lot of time in
Well,
Boston,
yeah.
and I moved to California and moved my way back.
Okay.
New Hampshire, the train that goes
I'm excited to
from my
see
town directly into Boston, so it's.
Oh, really?
I know we're getting close, I know you're getting close.
It's, Amtrak runs service from, yeah.
Okay.
And it goes through Exeter, which is where I live.
Okay.
So it's
No,
not a commuter
unfortunately,
rail,
we had
it's
technical
standard
issues, we
Amtrak
did
here
not
in
get it
Kansas
to work.
City.
That was the
Okay.
lead one we did last month.
Okay.
On the bright side. Oh, sorry to hear.
Yeah,
No, on the bright side,
exactly,
it was.
exactly.
I think all of our meetings are valuable. I think that one was maybe less important to have a recording of, I'll say. We were going through the material and
Would you
just
guys
playing around.
code the?
So there wasn't like learning of our yeah.
Python,
Yeah. So, yeah, and we'll be at actually next month, probably then, but maybe we will.
We're not. All the, I was using the API, you could tell.
So, the way the formal methods thing works
Well, the API.
is I have gotten a laundry list of copies, which I have gotten like 2/3 to 3/4 of the way done.
Either I ran out of budget.
And so then, I realized, oh shit, I don't have anything for next month.
But.
And so I looked
I'm
at
running
the
it- I'm
collection
running
of
it
things
on
that are
Raspberry
2/3
Pi
to 3/4 of the way done, and I'm like,
It's
grab
not, one of the
or
requirements that our
that we
program
have to
manager
have
for
a
this
special
contract
guest
had
speaker
was.
to meet benefits and stuff.
When I said to him, we're doing SaaS, he said, you can do SaaS, but you better use a store that runs on it. And so, okay, it runs on the
Yeah,
Raspberry Pi.
it's becoming
It's
popular.
quick
I
enough.
disagree with the idea that all of the theorem provers are dead. That
What
was
are
the
the
thing
things you guys
that
are
was
still
said
working
a couple
on?
times at the NASA Formal Methods Conference with the
What's it
official
called?
creators of the league. Agreed with that, it's like officially, I do not agree. Like, because not being the only theorem prover out there, I like it, but
They wanna see revenue,
the only one.
so.
Sure.
Figuring out how to get people's pace of what we're doing is one of the.
Yeah,
one of
no, like
the
the installation, so yeah.
but
What is it we do with the boxes?
Ensuring that.
The empty boxes we'll just put on top. Are we out? Are we totally out?
Yeah, I'll totally, first time ever.
Awesome.
They have a good.
I'm glad.
I'll go meet them.
Yeah, hold on. We'll put that on last. So we usually, just keep them over here.
Languages, because you're like trying to figure out like other ones to do, like.
So for example, was TypeScript that is like completely.
Yeah, we looked at a whole bunch of languages, some of them are.
Yeah, we'll update the meetup.com. Well, so Nat's formal
Or the people that are using
next,
Next, do they have.
Oh, next
a problem in
I
making
invested,
chaos?
I bought SDS.
Or should we look at like.
So it'll be,
That part.
But what I got
whether they do it in,
was
I think they usually try to do it in May.
I bought it at $10.
Scheduling meant that they needed to do it
I
in
think
April.
right now it's like 128.
Hopefully, Houston.
I would have bought more.
Earlier,
I think I actually bought it less
later,
than
later.
because it was like a pack, right? So I bought it for like,
And that's
I
part of
think
the
not
problem.
being, I felt like
Alright,
it was
One of the things we can do, how do you fit
for
that
like
into one
$6 or whatever, right?
One, two,
And
three,
then like I got a sign that it went like less than $6.
Not only are we trying to figure out.
Everybody
who
that
should
I
have
got
it,
my card.
it's also, who do we need to communicate and how do we need to communicate?
Yeah. And right now, I saw
So, like,
calls
just
for more
instinctually,
than, calls for like 180, for more than what I bought the
You know,
entire
of course you
contract.
can see
Because, like, I literally,
CI,
I took some calls at like 10, right?
It
And
feels
then,
like
yesterday, I had
closer in the
an
loop.
order set
Like,
for like
kind of,
2442, and like, one of the calls was like 2442.
Right, and so.
As opposed to the CI
At 180.
Yeah, we have a GitHub
That's like
action,
120.
because that's where I
It was
started.
120 yesterday.
But
now it's
honestly, most
128,
people I've
so.
talked to aren't actually doing git commit.
So it's kind of funny because if you actually look at the,
And so we've actually made
someone
it
did like a
easy
Wall
for
Street
us.
Bets post
So
about
you
it.
can plug it in to
Apparently
your,
like
whatever you're
SpaceX
using as
itself,
an
like
LCD.
the space
So that'll
launching
work.
itself, it's actually like a
But-
model. So apparently, like,
But
there's
also,
a
we just,
SpaceX.
what you
that's
saw
Starlink.
almost working, what you saw on the first
So
demo.
the space launching itself
is
is
that
like a 10% margin or whatever
has
it's called,
API
right?
keys
But
to
then
make the
the
call,
margin or whatever
the
they
API
call it
call,
for Starlink.
the agent is making the API call.
60%
And that's
whatever.
really where.
And
I think
because
the
of that,
vast majority
ASDS
of
actually
users
competitive
are.
with
talking also about
Starlink, they're not
putting
putting
it
it
in
in
an
SpaceX,
IP
right? So because
You said they were
SpaceX,
SpaceX.
well, yeah, because SpaceX has Starlink, right? So it's kind of like, they're basically competitive, like, the SpaceX listed as a competitor, right? So Starlink is like a space thing, actually.
But
But
just
at the same time, they,
where your
what?
head's at, your question.
Wait, what I said didn't make sense?
I remember
Are you
you
concerned with
I didn't bring
putting
enough
on
of that.
What's
Yeah.
ASDS? Are they launching? Are they,
Yeah.
are they,
Yeah, it's not like
Walked out, and I'm like,
Yeah.
oh,
their
never mind.
competitors starting?
Yeah.
Not
So
direct.
there's
Just found
one is
out.
like.
Your original,
But
your
the other one is
original
it's
broadcast.
a classic.
Yeah, and because SpaceX listed in
platform,
there
that
as
platform,
whatever, right? That they're
Far
a
easier,
competitor.
you can update a bunch of
No,
individual
for the
plans.
more
If
fundamental
there's a
reason
bug, you
that,
can go, or a
of course,
feature
this
or
is
whatever,
all
we can
sorts
fix
of
it
satellites,
with
so
a
they're
push,
competing with them on Starlink,
redeploy
effectively
in
competing
like a
with
couple
space
minutes,
program.
whereas if you've installed it on your computer, we now have to reach out to everybody who's got it installed on their computer and say, you need to update this thing.
It's also easier to control features and control.
I'm
Do you want
You know,
five
it goes in
languages?
there.
You get the five languages. If you want one language, pick the one.
Is the reason that you.
Oh, Charlie, by the way, like,
Python
if
is-
you, I know you all, you kind of like said on Jack Diode, like,
Or
Fooded, they
was
also sponsor, I think, like, their location, like, a 2410, for like Meetup.
Well,
Yeah,
it's-
absolutely.
it's
Possibility.
very,
Yeah.
Or,
Well, it's an interpreted language.
in Mandra, it's across the street, we
It's
get
plenty
them on.
fast now. That I was.
What?
In Mandra, one of their competitors,
Yeah.
but they're not really
Now it's
competitors,
stored out there, we've written all sorts of stuff.
they're,
Well, that's basis kind of nice, I think like that area, I think like they, well, when they have the meetup, like on Friday, it's like during the, like from 1 until 3, so that,
Yes.
there's no free parking at that
There's
time,
also
right?
ER,
I think after
food
6 there's
aspect
parking
to it.
there, so
There's a
it's
lot of
not
other
really
people
cheap,
using
right?
Python.
Yeah, yeah.
Sure. And so if we're writing in Python and we're eating our own dog food, then we can say, hey, we really support this language. But for IP protection, writing in C
Well, so you don't
or
like,
some
so
compiled
you don't
code
gonna like.
would provide us
Yeah.
additional IP
You gonna
protection.
send that?
But the state of reverse engineering
I
now
use
is such that it's like,
it.
eh.
Yeah.
I don't know if very.
And Docker containers don't solve the problem, if you
I'm not
can
trying to
code out of
explore
Docker
it against.
containers.
That's speculative.
Yeah.
SAS is really the way to do
Well, but I think because you were already in Tesla, right?
Maybe.
it. Well,
It all depends on the application.
So, there are certain customers that are gonna wanna run it on-prem.
So, yeah, that's what you mean.
And then
You were gonna
we
be
will
what?
take
Confused
everything that we
about
have running in a
like,
cloud
like,
environment, stick it
the
into a
prospects,
1U or
like
2U
they shut the
server,
business
and stick it in a
for
rack.
last long.
And sure, they can go break into that server
You still
and
think
stuff
that or
off
no?
and release it.
I haven't thought about
There's
it.
they took a lot of active effort to go get stuff out.
Well,
I
here's
gotta check that one out,
conceptually,
there's long-term
you're
damage
thinking
to
about
the
going
business
after
model.
the high value,
PR issues.
sort of.
Oh,
high
right,
value
right. I completely forgot that.
As
Yeah.
opposed to,
Okay.
I would say.
You remember me
Call
having
it-
this position,
No, no,
you
I
remember
remember.
having the earlier
Just
conversation, you don't remember.
quick feedback from a model.
Driving.
Ultimately, we
Anti-Tesla
want.
I forgot about
Ultimately, it's
it.
in
I
our best
remember
interest
now
and
that
our
you
investors'
mentioned
best interest to have a number of really good enterprise contracts, you know, like 3 to 5 year contracts, with steady revenue from that.
Awesome.
That's just the nature of being a startup, you want those big contracts that are steady and predictable.
Awesome, getting that all set up, getting the guest speaker.
But-
Yeah, yeah.
What was the story behind how you found them?
We also want to support the
It was,
individual engineers as much as we
the
possibly can.
free folks, so
And,
Lon
and
came
part of the thing
by
is you're
a
getting enough of
couple
that sort of top line
months
enterprise
ago,
level revenue.
or last month.
And it's a lot
The
easier
guy
to
was
go
back here.
support individual engineers. The
He's
freemium
from
model
Capital
just,
Plan.
it's like, okay,
He's
you're paying us
from
$25 a month for
And he
access,
was like,
just
he
so
was
you
like,
have a
wait,
little bit of friction.
Do this
and
call,
not
do
be
this
like-
shout out, do this shout out, do this
So-
shout out.
No,
I've
he's
spent a
not
lot
on
of
that part.
time writing open
Yeah,
source.
they're different,
using other
different.
people's open source projects.
Well,
and
they
things
know
like
each
that.
other,
We're
but
not
they're
walking away
different
from
parts.
supporting
Yeah,
each
so
other.
anyways, no, he came because he was like, wait, we're working with this company that's doing formal
Well,
methods
thank you guys
stuff.
for sharing.
And here we are
Thank you
at
very much.
Capital Factory, and we
Thank you.
apparently have a formal methods user group here, and so, yeah, so that was where that came about, so. Well, thank you again for coming out.
Thank you
Yeah,
very much.
absolutely, thank you.
Speaking, it was great, I'm glad you guys came out, and, anytime you're in town, feel free to drop
Yeah,
by.
we'll drop you, and you'll be
Yeah.
hearing from us about other things also,
Okay,
cause we're
cool.
gonna have questions.
Yeah, for sure, anytime.
Yep, thank you.
Yeah, let's see,
You need help carrying anything down?
no, this is it, On the way up, it was heavy because I had, 30 cans of soda or whatever, but now it's not too bad. Yeah, I think we're good.
Thank you all.
Yeah, yeah. So, what am I doing? Lights on.
I think like the air conditioning, I'm not putting it used to work here, but like today it was like really hot inside. Yeah, I really.
Well, when we came in, it was really, really cold.
Oh, really?
Yes.
Oh.
Yeah.
Well, that's because no one was